Supply and demand is the economist's primary tool to predict and explain changes in prices and quantities. Analysts follow a simple 7-step procedure to predict how an event affects the equilibrium price and quantity. First, sketch a graph with the price of the good on the vertical axis and the quantity of the good on the horizontal axis. Next, draw supply and demand for the good before the event occurs. Third, use the intersection of the supply and demand curves to identify the equilibrium price and quantity before the event occurs. Mark them on the axes. They are the initial values for price and quantity. Step 4. Identify whether or not the event shifts the demand curve for the good, and, if needed, draw a second demand curve showing the demand after the event occurs. If the event increases demand, the demand curve shifts to the right. If the event decreases the demand curve shifts to the left. If the event does not affect demand, the demand curve does not shift. 5. Identify whether or not the event shifts the supply curve for the good, and, if needed, draw a second supply curve showing the supply after the event occurs. If the event increases supply, the supply curve shifts to the right. If the event decreases supply, the supply curve shifts to the left. If the event does not affect supply, the supply curve does not shift. Next, use the intersections of the supply and demand after the event occurs to identify the new equilibrium price and quantity. Mark them on the axes. They are the final values for price and quantity. Step 7. Compare the initial price and quantity with the final price and quantity. If no curves shift, you predict that the price and quantity remain constant. The equilibrium price and quantity change if and only if demand or supply or both change. Let's use this process to determine what would happen to the price and quantity of Big Macs when the price of Whoppers increases. Step 1. We sketch a graph with the price of Big Macs on the vertical axis and the quantity of Big Macs on the horizontal axis. Step 2. We draw supply and demand for Big Macs before the price of Whoppers increases. Step 3. We use the intersection of supply and demand curves to identify the equilibrium price and quantity before the price of Whoppers increases. Our graph showed that the equilibrium price of Big Macs is $3 and the equilibrium quantity is 1,000. These are the initial values for price and quantity. Step 4. We identify whether or not the increase in the price of Whoppers shifts the demand curve for Big Macs. Since Whoppers and Big Macs are substitutes, the consumers want to purchase more Big Macs than before if the price of Big Macs is constant. Therefore, the demand for Big Macs increases and the demand curve shifts to the right. The curve labeled D is the demand curve when the price of Whoppers is low, and D' is the curve when the price of Whoppers is high. Step 5. We identify whether or not the increase in the price of Whoppers shifts the supply curve. Since the increase in the price of Whoppers does not affect how many Big Macs McDonald's want to sell when the price of Big Macs is $3, the supply curve does not shift. The number of Big Macs the firm can sell when price is $3 has increased, but the number that maximizes profit has not changed because nothing has made cost of production change. Since an increase in the price of Whoppers does not affect the supply of Big Macs, the supply curve for Big Macs does not shift. Step 6. We use the intersection of the supply and demand after the price of Whoppers increases to identify the new equilibrium price and quantity. Our example shows that the new equilibrium price is $3.50 and the new equilibrium quantity is $12.00. Step 7. Now we compare the initial prices and quantity with the final price and quantity. We see that the price of Big Macs increases from $3 to $3.50 and the equilibrium quantity increases from 1,000 to 1,200. Supply and demand analysis has 4 main predictions. 1. An increase in demand increases both price and quantity. 2. A decrease in demand decreases both price and quantity. 3. An increase in supply decreases price and increases quantity. And 4. A decrease in supply increases price and decreases quantity. Let's return to the questions posed in the video that introduced supply and demand analysis. Why does the price of gasoline rise in the summer? Why did prices fall in 2015? Why did price and quantity move together sometimes and in opposite direction other times? Let's start by talking about the difference between summer and winter. What else changes besides the price of gasoline? One big change is that people drive more in the summer because they use their cars for vacations. The increase in driving means that the demand for gasoline is higher in the summer than in the winter. As a consequence, supply and demand predicts that prices are higher in the summer than in the winter, and this is exactly what happens. Since price and quantity move in the same direction when demand changes, we expect to see quantity increase in the summer. This is also exactly what happens. Now let's see if supply and demand can explain the decrease in the price of gasoline between 2014 and 15. Another big change of the time period was a sharp reduction in the price of crude oil. U.S. companies used fracking to increase substantially their production of oil and natural gas, and Saudi Arabia decided it would no longer reduce output to keep the price of crude oil high. As a consequence, the price of crude oil fell from $98 in 2014 to $53 in 2015. The decrease in the price of crude oil increases the supply of gasoline because crude oil is an input used to produce gasoline. Since price and quantity move in opposite directions when supply changes, we expect to see quantity increase in 2015. This is exactly what happened.